Okay, so welcome back. In this video, we'll start to go into the actual specifics of coding with memory addresses and working with pointers. So the best way to demonstrate about pointers is to declare a variable I, and then we'll give that variable I a value 5. And then, so in the previous video regarding memory, I talked about how our C++ compiler in our computer will know how to take a chunk of memory for I, an address, and then put the number 5 in there. And so the easiest way to see exactly what's happening with that is to use a special operator. So I'll type some code in here and then I'll explain it in a moment. And let me make sure my code actually runs, so I'm not giving you a bad code example. Okay. So what we're doing is we have our variable I, and there's a special operator, this little ampersand here. It's called the address operator. And what this operator actually does is, and for anybody who knows what a reference is, don't get the two confused. In this context, we're doing an address operator. For those who don't know what a reference is, don't worry about it just yet. But so in this case, we are using the address operator. And so what the address does is, if we ran this code example without it, so we don't have that little ampersand in front of it, and we start without debugging here, it's 5. I should have updated the little label in front. But we're working with the, and let me rerun that. So you're not too confused. What we're saying is the value of I So the value of I is 5. And so in our example earlier, we said that's our envelope. If we have our mailbox, the address is some address, and we'll look at that again in a second. And then we have the value is 5. So let's copy and paste this line here. Oh, sorry about that. Okay. So now what we have is our value, and then now we're going to display our address. Okay, so now we have the value of I, and then we have some address. And so this may seem a little strange. You've got some numbers and then some letters. And I should explain what this is, and you won't have to really understand this too much in this course. If you take some other courses, depending the major you are, you probably have worked with alternative number systems. So the number systems that we work with are 0 through 9. So there's so it's what's known as base 10. And then once you go past 9, you put another number place. So we go count up to 9, and then we start off with a 1 in the next place, and then we add a 0 to the end. So then we get 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20 goes in the next place. So some of you have probably heard before that computers work with 1s and 0s, and so that's what's known as base 2. And so the same thing happens, but instead of being able to count 0 through 9, the only values are 0 through 1. Well, what happens is when you get really, really large numbers, if you can only count 0, 1, 0, 1, 0, 1, the representation of that, when you're trying to read that as a human, becomes really, really huge. So this number right here is actually a 64-bit number. So imagine this being represented with 64 1s and 0s. It becomes very hard to read. And so what we do is we come up with another alternative numbering system that is compatible with base 2, known as base 16, and sometimes you'll hear that referred to as hexadecimal numbers. And so instead of just counting 0 through 9, we count 0 through F. And so in addition to 0 through 9, we also have A, B, C, D, E, and F. And so what that is, those are actually numbers. So don't worry about what that is too much just yet, but you can actually convert that into a base 10 number that you're used to. And so before, when we were working with the addresses of 1000, 1001, 1002, these are much higher in memory because the typical computer has so many things running at any given time that we end up with much higher memory addresses. And so don't worry about that too much, but understand that this address here is a number, and it's somewhere in your computer, and it's an address just as valid as the address on your mailbox, and this is the envelope. This is an address inside your computer memory, and this is some value. And just so you know, and maybe this is where the Postal Service example falls apart a little bit. You can only have one thing in that piece of memory at a time. So unlike your regular mailbox where I can stuff a bunch of mail in there, you unfortunately only have one value in there at a time. So that's where the example analogy maybe isn't perfect, but just know that at each memory address you can only have one thing there at a time. And there's a good reason for that, is because if you tried to put multiple things in there at one time, then you'd have to have another memory system where you'd start to try to figure out which part of that memory address you're working with. And the simplest way is just to simplify and say, okay, we're going to come up with a rule system that we can only have one thing in a piece of memory at any given time, and that works out because then it maps directly to the wires on the RAM and the transistors and all that. So it just happens to work out really well and makes things simple. Okay. So you hopefully understand the address part and then what's in that address. And so there's a kind of a special thing we can do that, and that's a pointer. So we have our and actually, before we get into pointers, just so you saw that in action, I'll go ahead and stop the video here, because if I keep the videos shorter, it makes it easier when you're reviewing the videos later, and in case I make any mistakes and have to re-record these, it's much easier to record a short video. So the next video will actually go start into the actual coding of pointers and seeing some of their properties and attributes.